other information applies to you regardless of what crop or commodity that you have. But as James said before, if for some reason you would like a copy of the livestock presentation, we can make that available to you. So what are best management practices, or BMPs? You know, probably those of you that are participating have a various different backgrounds. Some of you may farm, some of you may be homeowners, some of you may have livestock, you know, but you may have heard of best management practices or conservation practices, or you may have not. But what are they? They're ecologically and economically sound production practices. They protect water resources and maintain profitability. And why is that important? Because obviously, if putting in these practices to address an environmental or resource concern was too costly, most people are not going to do it. So they have to protect the water resources while also keeping you profitable. They're based on years of research and demonstrations from universities such as LSU, with the Ag Center, but also universities in other states and research institutions. And the standards and specifications published in our BMP manuals are also from the NRCS Field Office Technical Guide. The BMP manual design, and I'm going to show you what they look like in just a minute, at the request of producers, was actually grouped into different sections. And this was done really to make it easier to use, easier to find practices under these specific sections. So we're going to go through some of these this morning. The first one is soil and water management. We've got pesticide management, nutrient management, and then some general farm BMPs, which apply to your farm regardless of what you grow or what you raise. These are the colored BMP publications that were printed several years ago. This is actually a link to these BMP manuals. If you get on the Ag Center website, you can type in the search engine for BMP publications and it'll bring it up. We have them for all the different commodities across the state, as you can see, and they're really good resources. We don't print these anymore for the most part because they're just too costly. Almost all of our publications now are available online though. But these, when they were printed, were sent to our research stations and our extension offices for people to come in and pick up, you know, to keep as a resource. This is just, you know, a page I took off of one of them off the livestock BMPs. They're full of a lot of information, you know, why BMP is important, the practical side. They look at the different beef management practices, buffer strips and things like that. So there's a lot of information. It's very easy to read. It's very easy to access in the specific crop or commodity that you might be looking for. So we're going to roll into the first section of the BMP manuals, looking at soil and water management and why this is so important. So farming has been around for a very long time, as you can see. This picture is actually from ancient Egypt around 1200 BC. It's been around for a very, very long time. And with that, a lot of challenges along the way have occurred, and you know, especially with environmental concerns we've had to address in the last, you know, 50 to 100 years. Because most of these traditional management practices have left the soil bare and exposed to years of erosion, and that accounts for a lot of nutrient depletion as well. So a lot of these practices have changed, especially over the last 20 or 30 years. Why have they changed? Your economic situation. You know, producers don't make the same amount of money every year. Your financial status is not the same. That could be due to crop prices. It could be due to the number of cattle you have. It could be due to a personal situation. But everyone's economic situation has changed, and that has dictated maybe which farming practices you have implemented, which ones you don't practice any longer. Fuel, equipment, seed, and land costs obviously all have gone up. That probably will not change. You know, you've got technological advances with equipment, GMOs, GIS technology. Great, they make your farming more efficient, but there's a cost to them as well. So, you know, with the cost of these technological advances, that's going to change how you farm. It's going to change what you plant. It's going to change the equipment that you buy to farm that particular, you know, crop. Also, pending environmental rules and regulations. And again, in Louisiana, we do not have very many environmental regulations that we have to abide by because we're very fortunate. But these are all things that have caused farming practice to change over time. So some of the surface water contaminants that we pay a lot of attention to are the sediments, nutrients, and pesticides are the main types of contaminants in our surface runoff. Surface runoff being any water that's running off of a field, a yard, a golf course, a parking lot, anything like that, any type of surface runoff. Sediment is the largest pollutant by volume of surface water in Louisiana. Pesticides and plant nutrients are usually absorbed onto these soil particles, so it kind of acts like a magnet. You have the soil particle, then you've got the contaminants and the nutrients that attach themselves to that soil particle, so when it's washed away or runs off the field or the pasture or any type of exposed land, it's taking those contaminants with it. Things that we pay attention to in soil and water management and how they can impact the quality of that surface water is wastewater. You've got landfill pollution, air pollution, fuels, septic systems, chemicals, pesticides, animal waste. All of these things have the potential to contribute to our water quality issues and things that need to be addressed. This is just a cartoon picture basically of what is happening, of all of the potential inputs that can impact our water bodies, from pesticides and fertilizers, animal waste, automobiles, hazardous waste, urban runoff. I mean, so you see it basically covers our entire landscape, whether you're in urban or in rural areas, gas stations. They all can get into our surface waters and possibly even into our groundwater. So we need to try to implement some of these practices to help negate the negative effects of these. The problem that we see and the problem that causes the sediment to get off the field and get off of these other areas is erosion. The erosion process is pretty simple. It's something you don't really think about, but it's got three phases: the detachment, transportation, and deposition. So basically the soil particle is picked up when water, whether it's rainfall or irrigation, moves across the landscape. It's picked up, then it's transported, and it's deposited somewhere else. And usually it's not deposited where you want it to be. It ends up where it's, like I talked about earlier with the rice fields, it's clogging up a ditch, or it's being deposited somewhere that's going to cause a problem. So do we have erosion here in Louisiana? Now, I'm from the northern part of the state where there's actually a lot of hills, but there's a large part of our state that's actually flat. We don't really think about erosion happening in the flat areas of Louisiana. One of the major goals in production ag is finding ways to remove the water off the fields fast enough to keep the crops, from drowning. That's why we grow a lot of things on rows. Erosion is something that happens in a lot of hilly landscapes where water's flowing downhill, right? I mean, that's what we think. We know this is erosion. The scars are left long after the rainfall event or the storm has passed. And typically, if they're not addressed, these gullies and this erosion gets worse over time. This is erosion. Again, it's pretty easy to see. This is the edge of a field. I don't know what crop is growing out there, maybe corn. It's hard to tell, but there wasn't a sufficient stand to help keep some of that soil in place. They had a heavy rain, and as you can see, a lot of the soil has washed off. Okay, is this erosion? This is three pictures. The one on the left is actually a field being pumped off of a newly formed rice levee. As you can see, the water looks like chocolate milk. It's very turbid. There's a lot of suspended sediment in that water. The picture in the middle, you have some dairy cows at the edge of a stream bank. You can see the erosion along the bank of that where they've been walking up and down into the water. And on the right, that picture, you can't see the house itself, but it was a newly constructed house. And this was just the soil up against the base of the house that had not established a lot of grass or vegetation yet. So when you look at all these, does this make you instantly think erosion? Maybe, maybe not. But in agriculture, even the fields that have very little slope, you can have significant soil loss that can contribute to our water quality problems. So what does that depend on? It depends on the erosion potential of a site. And what that is just the estimate of the quantity of soil that could be removed from a site due to erosion and transported somewhere else. There are several things that actually affect erosion or erosion potential. You have rainfall, depends on the intensity and duration. With the storms that we've had the last 2 months, there's been a tremendous amount of rainfall in certain parts of the state. And I'm quite sure there's probably a lot of erosion that has happened in areas where you did not have any kind of vegetative protection. Soil type and structure also have a lot to do with how much potential there is for erosion, the topography and management of that soil or that field. And management is circled because that is one thing that we can change, we can address. We have no control over rainfall, soil type, and structure for the most part. Your topography, maybe, but your management. Some of your management changes or practices can change whether, you still have the erosion that you have. You can minimize that by implementing certain practices. This is one practice. If you can see that, it's a man-made practice that increases erosion potential. Rice producers have come a long way in addressing a lot of the water quality issues that first came up because many of them still use the water leveling method when they would plant their rice. Many of them now do, no-till or drill seeded or whatever. So there's not very many of them that are still water seeding like this, but this obviously has the potential to stir up the water, the sediment is in there, and then they pump the water off of the field, which removes the sediment from the field, but it moves it into a drainage canal or a ditch. Some other impacts of field runoff, you have surface water quality impacts, unsafe drinking water. It can affect your irrigation water because of contaminants in there. Again, off-site sediment deposition, all of that soil is running off and going somewhere. It's being deposited somewhere. It can affect your recreation. As you can see the picture in the middle, it says, no swimming or be on alert, when they have high E. coli or fecal coliform levels or whatever, you can't swim. You can't get in the water. You can't use that recreation. And then you also have oxygen depletion and fish kills. And James talked a little bit about that, about hypoxia and the problems that we have in some of our water bodies with low oxygen. You also have economic impacts. The soil loss cannot be utilized for production. Many times the soil that's being run off or coming off of a field has that precious organic matter and topsoil on it that has a lot of the nutrients, that has a lot of the microbial populations and things that are, right there at the surface of our soil. So when you get a rain and that runs off, then a lot of that has the potential to go off with it. As well as your nutrients. If you've put out fertilizer and it rains, a heavy rainfall enough to move some of those nutrients off, then you've lost the effectiveness or efficacy of that fertilizer where you needed it and also moved it somewhere else where it can cause problems. And the same with pesticides. There's an estimated global economic loss of soil erosion of about $8 billion. Reduced soil fertility, decreased crop yields, and increased water usage. So there's a lot of potential impacts when you have runoff that have contaminants, sediment, pesticides, and things like that in the runoff. One problem that we face is this is the Mississippi River Basin. You've probably seen some of these pictures before, but it's a tremendous, tremendous watershed. Covers over 1 million square miles. It's all parts of 32 states and 2 Canadian provinces. It covers approximately 40% of our continental United States. And all of that has the potential to drain out the mouth of our Mississippi River. So that's one reason we have a lot of problems in the Gulf of Mexico, right off the coast, what we call the dead zone or the hypoxic zone, because all of those nutrients that are coming off of ag, processes are coming off of farms, coming off of wherever nutrients are applied, if they're not taken up, if they're not filtered out or absorbed or taken up by the plant, they have the potential to eventually make it out the mouth of the Mississippi River, which causes a lot of problems with our fish and aquatics right here at the Gulf of Mexico at the bottom of our state. And as we said before, our own state, we have 10,000 named water bodies. That is a lot of water, and it eventually the Gulf of Mexico into where you can see the Chaffalaya Bay and down there further south on the coast. And when all the nutrients and sediments, leave the fields, leave the farms, leave the homeowner's yard, wherever, that potentially causes problems when that sediment and nutrients and pesticides and things end up, on our coastline. So why are they practical? There's a lot of reasons actually, but not all of the pollution can be attributed to ag operations, but the public's perception is that it's always at least part of the source. And it's not hard to find the pictures like that I have on the right, where it says agriculture plays a significant role in the pollution of large water bodies. That's called helpsavenature.com, that website. You also have one below it, Eat for the Planet, where it gives you percentages of basically agriculture's, especially livestock's, contribution to some of the problems we have with greenhouse gases and things like that. So, whether that information is true or not, it's out there. And we as a industry, as a community, as agriculture, need to do a better job of getting out the positive things that we're doing to address some of these concerns. So soil and water management practices, and these are just a few. I mean, there's a ton of them, but I just pulled a few of them out. And again, the picture on the bottom right is a picture of the NRCS's website with the field office technical guide. And there's a ton of information on these practices, and as well as other practices that gives you more specific, detailed information on what's out there. They offer technical assistance, but they also offer cost share assistance in implementing these practices as well. And one thing I actually wrote myself a note to remind you, by participating in the Master Farmer Program, if you do apply for EQIP funds through NRCS to put in conservation practices on your farm, you do get extra points on the ranking sheet for participating in Master Farmer. So NRCS wanted to reward the producers that were involved, that were participating in this program, by giving them extra points, and there's money set aside for people in the program to be able to get funded to put in some of these practices. So, once you're done, if you are moving in that direction, when you contact your district conservationist, make sure you tell them that you are in the Master Farmer Program, and they can confirm it with us and confirm it on the website to be able to give you those extra points and have those funds available. But moving on to some of these practices that we're going to talk just a little bit about: irrigation, land leveling, land smoothing, filter strips, grass waterways, cover crops, conservation tillage. Some of these can go back and forth with livestock, like cover crops and conservation tillage. That can be utilized in pastures as well as on cropland. Irrigation, land leveling, basically the definition is you're reshaping irrigated land to a planned grade. This is to get more efficient, basically more efficient flooding while minimizing erosion. So you want to be able to get water on the field and off the field while you're minimizing erosion. Land smoothing, I thought this was kind of funny. You can do it the easy way or the hard way. As you can see, they've been doing this for a long time. We don't have camels over here, thank goodness, or we'd never get anything done. But land smoothing practice has been around for a long time. It's established to smooth or level land. Again, a lot of that's to get water on and off a field, but remove soil from high spots or fill in low spots for proper drainage. Obviously, you don't want a field that floods on one end of the field and you can't get your crop out, or you can't get in there to fertilize. You want to make sure all your fields are relatively flat, or at least have some type of drainage where you can get the water off of it. Filter strips. This is a picture of a filter strip. These are areas of grass or some type of permanent vegetation used to filter sediment and other contaminants from the field in the runoff before entering a water body. As you can see, there's a little drainage area, a little ditch there. There's a lot of green grass, heavy vegetation, which does a really good job at trapping the nutrients and sediment that are coming maybe from those fields that are being drained into that ditch. An effective filter strip can trap as much as 70% sediment and over 50% nutrients. So, you know, these can be very good at addressing some of these issues. We have grass waterways. You can see there's a picture on the left where it's a natural or shaped to convey runoff. Basically, water is running through there, and you want it to be some type of vegetation, permanent vegetation, hopefully, to filter sediments and contaminants. If the picture on the right, you can tell this is an area that's needing a grass waterway. There's a lot of erosion. There's a lot of exposed soil there. Some type of vegetation planted there, you know, could do a tremendous job in saving some of that soil and sediment from leaving that field. Now, obviously, filter strips and grass waterways, you have to maintain them. You can't just, you know, let them grow up or plant them and then just leave them. If they're doing their job, they're going to be collecting sediment over time. So there may be times where you have to smooth them out, you know, in order for them to be effective again. So you do have to maintain them. Cover crops. This is something I told you about earlier, that there's been a lot of interest in. There's a lot of projects and trials going on across the state addressing a lot of different aspects to cover crops and the benefits of them. Hopefully that we can come up with some recommendations. NRCS has cover crop recommendations as far as species and you know, planting information and things like that. But we're also working on, again, looking at different soil types and seeding rates and things like that. So hopefully when you're looking at planting a cover crop in your area, we'll have more specific information or recommendations on what's the best thing to grow in your situation. But these are planted when the primary commodity crop is not growing. Usually it's in the wintertime. There are some summer cover crops as well, but they do a really good job at protecting the soil from erosion, keeping the sediment in the soil in the field. They help filter runoff waters to reduce pesticide nutrient losses. They help to maintain or increase organic matter and nutrients because some of these cover crops are really good scavengers of soil nitrogen. Some of them, like the legumes, actually produce their own nitrogen. So when that cover crop eventually dies, it releases nitrogen back into the soil for the cash crop that's planted after that. So there's a lot of benefits to these cover crops. They're not all listed here, but they can do a really good job at improving the soil health, the soil structure. Your microbial populations increase, you know, with cover crops. So that's something to really think about if you're looking at ways to actually improve the soil health of your crops. These are just some pictures. Crimson clover, tillage radish, and cereal rye. These are all pretty common winter cover crops in Louisiana that we've done some work with and had some really good results. Conservation tillage is, like I said, has been around for a long time. It goes all the way from, you know, minimum tillage, strip till, you've got straight no-till situations, and we've got farmers in the state that have been no-till for many years and have been very successful with it. It's not for everybody, but I think everybody has the potential to implement some type of conservation tillage to help reduce that soil erosion potential and compaction. It helps reduce runoff of nutrients and pesticides. It does require residue management, so you are leaving some type of residue or stubble out in the field. It may require greater reliance on pesticides depending on whether that causes a problem. If the residue over the wintertime, maybe we don't have a really cold winter and maybe some of the insects, you know, overwinter in that residue, then that may be a problem when you plant the next spring. But there's, you know, there's things out there that you can do to address that. It can improve soil organic matter over time. You're leaving residue out there, something for the microbial populations to feed on, to get energy from. And it also reduces your cost of equipment operation because obviously the fewer times you make trips on the field, the less fuel you use, the less labor you have to pay for and things like that. It can also improve air quality because you're keeping that ground covered. It's not open to exposure where a lot of wind would kick up the dust and you know, push it across a highway. So there's a lot of benefits to implementing some type of conservation tillage. The residue management, the definition states that the systems have at least 30% of last year's crop residue on the soil at planting. This is just a way to estimate. I actually looked that up. But if you use a measuring tape, you count the number of times the residue crosses the tape over approximately 100 inches. It said you could do it over 50 inches and multiply times 2, but that gives you your percent residue cover. If that's something you're not sure about and you want to know, you can call in RCS and have someone come out and actually, help you estimate the amount of residue that you still have on your field, so you know if you're leaving enough, if you need to do more. So does organic matter matter? That's kind of a play on words, but if you're not very familiar with what organic matter does or how important it is, it absolutely does matter. It tells you at the top of this slide that healthy soils, which have a decent amount of organic matter, have a higher water holding capacity. So every 1% increase in organic matter can result in up to 20,000 gallons of available soil water per acre. That's a lot of soil moisture that is critical to the plants, especially in times of drought. So what exactly is it? Soil organic matter is part of, as you can see the picture on the right, this is a soil particle. A soil particle is made up of 25% air, 25% water, 45% mineral particles, and about 5% organic matter. And of the organic matter, that's actually broken down into organisms, roots, or root pieces, and humus, which is a very stable organic material that takes a long time to break down. So obviously, the more organic matter you have, the better your soil is probably going to be. But it's made up of dead leaves, animal residue, manure, organic material, and all of this has to be decomposed by microorganisms. So again, the more microorganisms you have in that soil, the more organic material they can decompose and add nutrients to the soil. Certain things can affect soil organic matter, like temperature, high moisture, and oxygen can determine organic matter buildup. And obviously, the more times that a field is cultivated, that breaks down the organic material, and your organic matter tends to go down with a lot of cultivation. So why is it important? Again, it provides nutrients and habitats for the organisms living in the soil. And to be honest, I didn't pay that much attention to that part of organic matter until I started taking classes on soil fertility and things like that. They really play a big part in how healthy the soil is and how well, it provides nutrients for the plants that you're trying to grow, as well as being sustainable. It binds soil particles into aggregates and improves water holding capacity, which again is very important in a lot of parts of our state when we have a drought. The more organic matter you have, typically your plants are not going to be as drought stressed. Each 1% of organic matter can release up to 20 to 30 pounds of nitrogen, 4.5 to 6.5 pounds of phosphorus, and 2 to 3 pounds of sulfur per year. So they are contributing nutrients to the soil. Affects plant nutrient availability, and tillage and burning accelerate the decomposition of organic matter. So again, some of these conventional practices of the tillage, the cultivation, as well as burning residue can accelerate that, and your organic matter content can actually go down. So how do you improve or retain this organic matter? Reduce or eliminate tillage as much as possible. Aeration of the soil increases the decomposition. Reduce erosion. Topsoil contains organic matter and it gets washed away in the runoff that again usually ends up in some water body. Increase root growth. Properly fertilize, do soil testing. Put out fertilizer when you need it to. And grow cover crops. This is best combined with tillage reduction and erosion control. So we're going to move on to the next section of the BMP manuals, which is nutrient management. So what is nutrient management? I'm sure a lot of you are pretty familiar with some of this, but you're managing the rate, source, placement, and timing of application of plant nutrients needed for plant growth. Basically, you're looking at nitrogen, phosphorus, and potassium as the three major nutrients, but there are other nutrients that come into play. So what is the purpose of nutrient management? You want to budget and supply nutrients for crop production. You want to know what nutrients you have out there in the soil, what nutrients that your crop needs, whether it's corn or soybean, pasture, whatever it is. You want to know how much nutrients is needed to produce your maximum yield. but you don't want to put so much that you may have a negative environmental impact or water quality impact because of it. You want to improve your profitability, and you want to actually improve the physical, chemical, and biological condition of the soil. So you want to improve the soil health without any type of negative impacts. Non-point source pollution by nutrients, we talked a little bit about that already. But basically we're talking about nitrogen and phosphorus as far as causing water quality problems. Excess nutrients of these two into surface waters can lead to oxygen depletion and the hypoxia issue. Both of these are used extensively in ag production. And while they're required for all living things, excess amounts, in a naturally occurring like ecosystem or water body can cause all kind of problems. Excess nitrogen in water has been linked to Listeria outbreaks on the East Coast, and it can also cause health problems for infants in drinking water. So obviously you want to minimize the amount of nutrients that can get into the surface water. Okay, this shows a picture where phosphorus was actually injected into a lake, and then you see one to the right of it where there was no phosphorus. Just visually, you can see there's a difference from this aerial view. Excess nutrients stimulate algal growth, which causes a green or greenish brown appearance. So what is that greenish brown appearance? It's algae. You can see the picture on the left. This is an up close. This is what happens. Algae start to reproduce. Sometimes they can actually have algal blooms that become toxic. What they call I think it's in the dead zone, it's the red tide, where they actually become toxic to fish, and it can make people sick as well. So obviously this is not something you want to see, but this can be a result of too many nutrients getting in the water. This is called the 4R principles of nutrient stewardship. It's pretty common if you look this up on the internet. The International Plant Nutrition Institute kind of came up with this, and a lot of nutrient management is based around these 4 R's of best management practices. They're looking at the right source, the right rate, right time, and right place, like we said in the beginning. All they want you to do is match your fertilizer type to your crop needs. Do you put organic? Do you put synthetic? Do you put liquid? Do you put dry? Right rate, right amount of fertilizer. That is all coming back to soil testing. You have to know what's out there to know how much your crop needs and how much to put out. The right time, make sure your nutrients are available when crops need them. You don't want to fertilize before any crops get in the ground. There's certain timings that you have to put fertilizer out to maximize that crop growth. You have to know when that is. And the right place. Keep nutrients where crops can use them. Obviously if they get washed off of the field, the crops cannot use them. So, being able to apply what application method you use, whether you inject your fertilizer or whether you broadcast it, that's something else to consider too. So just following these 4R principles of nutrient stewardship when you're applying nutrients can go a long way in figuring out, how to apply these without any kind of water quality issues. Nutrient management plans, you may have heard of these before, but who has to do them? Individuals receiving NRCS cost share or technical assistance. If you have an operation listed as a CAFO, or if you're using animal waste, whether you poultry litter or some other type of manure as an organic type fertilizer in your operation. In the future, operations applying nutrients in watersheds listed as impaired due to excessive nutrients by DEQ. So what does this nutrient management plan consist of? There's a lot of information that you'll work with NRCS on. They look at your soil test results, farm maps, yield history to establish a realistic yield goal, your records on nutrient application, like how many times you put out fertilizer, when did you soil test last, and they make up a nutrient balance sheet, your inputs and your outputs. Then they look at the recommended application rate, source, timing, and method of application to minimize runoff to surface and groundwater. So it's basically a plan on how you're going to put those nutrients out. There has to be a balance. That's what all this is about, whether it's the pesticides, the nutrients, the erosion, everything has to be a balance. But we can do certain things to address the environmental issues that we have. And with regards to nutrient management, you look at your inputs and you look at your plant nutrient requirements and you find a balance. Okay, the next section we're going to go through real quickly is the pesticide management. And I'm sure all of you put out pesticides, whether it's just in your home, maybe on your fields, maybe in your pastures, but you're familiar with pesticides and mostly what is required. So what kind of factors do you have to take into consideration, when you're thinking about putting out a pesticide? What are your pest infestation levels? I mean, why are you spraying or putting out the pesticide? Obviously, you have an insect problem, whether it's around your house or out in the field. You've swept, your consultants told you it's time to spray, or you notice that your crops are not doing well, or whatever. You notice there's a pest out there and it's reached a level that if you do not address it, you do not take care of it, that it's going to cause some type of economic damage or injury. Field conditions and surrounding areas, that's something to consider, and the weather forecast. When it comes to the pest infestation levels, if you don't have a consultant or salesman that maybe visits you, there's a lot of information that the Ag Center puts out. As you can see on the screen, an insect management guide, a soybean guide, there's a suggested chemical weed management guide. All of this is available online. You can also contact your county agent if you're not sure maybe what you can spray, and a lot of times they will give you recommendations to do that. The surrounding conditions, again, are there schools or populated areas close by? Non-GMO crops or sensitive plants. I mean, obviously you don't want to spray something and it possibly drift into your neighbor's vegetable garden and wipe it out. Are there tree lines and power lines that might get in the way? Surface water, streams, or canals. You have to be very mindful of any place that is around your field or farm or wherever you're going to be spraying that might be negatively impacted if a drift or something like that occurs. The weather forecast. Most farmers watch the weather more than anybody I know. But with that being said, you still have to pay attention when you're going to spray. What is the wind speed and direction? What's the probability of rain, which obviously can change in a moment's notice, especially if you're applying a pesticide that has to have water to activate it or rain to activate it. So you want to make sure there's rain coming if you're putting out, one of those pesticides, herbicides. If rain is needed to activate it, like pre-emerge. And then potential flooding. If like the flooding that we've had the last few weeks, that's something to consider. Do you put out a pesticide or herbicide prior to that because you want to, kill the weeds that's out there before the rain comes? There's a lot of things you have to evaluate when you're considering putting out a pesticide. So some other factors to consider. Is it recommended for the intended crop? One thing that we always say, and LDAF will tell you, and NRCS will tell you, the label is the law. You have to follow the label. It doesn't matter if your neighbor or somebody said, oh, well, I used this on this and it worked. If it's not listed on the label, it's against the law to apply it in that manner. Most of these should be based on recommendations from consultants, crop advisors, the Ag Center. Again, the label is the law. The selection should also be made with the understanding that there may be an environmental impact. You do not necessarily want to kill every insect in a field because you have pollinators out there and things like that. Beneficials, other non-target organisms, maybe some endangered species. You may also have some surface water nearby, so you need to consider that. And also the cost. I mean, obviously that's a big reason to consider why you would put one pesticide over another out. Some other factors to consider, you have to look at the characteristics of the pesticide. Certain pesticides are readily water soluble. They're more apt to leach through the soil profile than those that are not soluble. Those chemicals can be absorbed. They're bound tightly to the soil particles. So when the soil runs off after a heavy rain or irrigation, those chemicals go with it, or they can go with it, I should say. Some of the pesticides are very volatile, which means they have a high vapor pressure. They're more apt to volatilize and move from the target site, which they would drift onto somebody else's field or yard or whatever and cause some damage. The degradation rate basically is the rate at which that pesticide dissipates after you apply it. A lot of people call it the half-life of the pesticide. that particular pesticide is subject to degradation. It's broken down by sunlight, by various things really, but sunlight and microorganisms in the soil. And the longer it takes for that chemical to be broken down, the more persistent that chemical is, and this can cause problems, which means you don't necessarily want it in the soil for a long time. There may be plant back restrictions or harvest restrictions or whatever, so you have to pay attention to that. Sometimes the water table can be very close to the soil surface, and it may be easy for a water-soluble chemical to leach into and contaminate the groundwater, so obviously you don't want to do that. Your type of soil plays a big part in this also, because if the soil is really sandy, if it's coarse, it's very porous. It's very easy for water and other chemicals to move down into the soil profile. If the soil is heavy, like a clay, it's going to have more organic matter, which typically clay does. The chemicals are going to be absorbed to the soil particles and only move when those are washed off the field, but there may be a higher runoff potential. So things kind of play into it when you're trying to decide which pesticide to spray. Some other things to consider, the method of application. You should think really carefully, is this something you want to do by air? Is it something that you want to do by ground? Which is going to be most beneficial. A lot of people, and obviously, spray by air if they have to, because they prefer ground equipment. And that's okay, but you need to think about what is the most effective method of application for you. If it's not maintained properly, no matter what your choice is, the application is not going to work. Something a lot of people forget about is calibrating their equipment. If it's not properly calibrated, it's going to be a wasted trip. You either have over applied it and wasted money, and it may actually be an illegal application if you've applied more than the label says that you can. If you under apply it, you're not going to get the control that you want, and you may have to reapply. So you're talking about spending a lot of money just from calibration problems. Mixing and loading is something that you need to be very mindful of, because it can cause problems with the mixer, the loader, whoever's spraying the pesticide. Be very, very careful when mixing and loading, and be sure and follow all of the instructions on the label. And the biggest thing, or one of the biggest things, is to keep your records. That is becoming more and more important. The Ag Center has record keeping books that you can get online. You can go to your county agent's office. There's things online that you can, if you just Google record keeping books, there's things online that you can use it on there. But before you choose a method of application, just reassess the area where you want to make the application and take into consideration all the environmental factors, that may be affected by this application. So the pesticide cycle, this is basically showing you that when you spray a pesticide, what can happen to it, what does happen to it. The plant's obviously going to take it up. That's what you want. Some of it's going to drift off in particle drift. Some of it's maybe drifting off, maybe volatilizing and moving off. Some of it may end up in runoff, surface runoff off the field. What gets into the soil is going to be broken down through the degradation. Some of it actually may percolate through the soil profile and leach into the groundwater. So a lot of different things can happen to that pesticide once it's actually applied that we don't really think about. But each of these has the potential to cause a problem in water quality, if we're not careful. Mixing and loading, this is just a reminder when you are mixing and loading, and if any of you are spraying, you probably know this already, but you never want to leave a hose, without a backflow prevention, because sometimes if the pump will go off, the chemical or pesticide is siphoned back through the hose. I know this happened in Point Coupee Parish years and years ago, and someone was actually pumping, they had two tanks. They were pumping water into a gramoxone tank, which is paraquat, which is a herbicide, a non-selective herbicide, and it can be very harmful if it's swallowed. Well, it got back siphoned into the water supply and caused some problems there. So just be very careful when you're mixing and loading pesticides, that you don't have any of these problems. Remember to fill the tank with water first. Keep a 6-inch air gap between the hose and the tank. And always have those anti-backflow devices, just as the check valves on the pumps, like we were saying, to prevent any pesticides from getting back into the water supply. Fill your tank from a hydrant at least 100 foot away from the wellhead if possible, or use a hose that will reach 100 feet. Now, those are just recommendations. Obviously, you can't always do that, but that's what they're recommending. So your pesticide application, again, do things to minimize your off-target movement or spray drift. Some of the things that actually will affect your spray drift: wind speed, and that goes back to checking the weather before you apply pesticides. Boom height boom can actually cause a drift depending on whether it may be higher than it needs to be. That's something that you need to look at and look at the label. Distance from susceptible crops like garden or neighbor's land or whatever it is, you need to figure out, is there potential for that application, if drift occurs, to get on these non-target areas and cause problems. And then spray particle size, nozzle size, and selection determine this. If you're spraying a pesticide, you probably already know that there's different nozzles out there, and certain ones are more prone to drift than others. This is just a graph from one study that shows what the application errors are with pesticides. Nozzles, 26%, applicator, 38%, physical, 23%, and others, 13%. So the applicator errors, are almost 40% of the problem. So a lot of that can be addressed and can be taken care of to reduce the potential for those pesticides going in places they don't need to. Calibrate your equipment, check your nozzles frequently. That's just all part of it. For there to be a problem, such as a faulty application or whatever, to check your equipment and check your nozzles. So your pesticide container disposal and spills. This is something that really needs to, I guess you need to pay attention to if you are applying pesticides. In order to clean the containers and application equipment, you can either triple rinse it or you can pressure rinse it. To triple rinse it, you fill the empty container with water to about 10% of the volume of the container. You swirl it around and then you drain it. You do that 3 times. That's why it's called triple rinse. To pressure rinse, you actually purchase a nozzle and then punch a hole in the side of the container and put water in there and rinse it out and dump it out. So at that point, once you've done that, the pesticide containers, you don't have to take them to a landfill or anything, but you can be disposed of for recycling or whatever, as long as you rinse them out prior to. If you have any rinsate, it says disposal of rinsate, you can actually apply that back to the field because it's a diluted amount of pesticide. Don't apply it anywhere you're not supposed to, but you can actually use that on the field or wherever you had applied the original application. Pesticide spills of over 1 gallon of liquid and 4 pounds of dry, you have to report to the Department of Ag and Forestry within 24 hours or within 3 days in a written form. I mean, obviously this is, so they're a regulatory agency, but over pesticides, and they need to know if there's some type of possible contamination. So the location and storage, or location and construction for the pesticide storage, a lot of this is common sense, but you'd be surprised at where people end up storing and what they end up storing pesticides in, like Coke bottles, Gatorade bottles. They put it in containers with no name, so they have absolutely no idea what's in it, when it was purchased, or anything else. I mean, obviously that's not something that we recommend. The storage buildings itself should be somewhere that's not prone to flooding if that's possible. And they should be dry, well ventilated, preferably a concrete floor in case there is a spill. You can, clean it up pretty easy. You should have some kind of signage, as you can see, that pesticide storage on the outside, so everyone knows what's in that building or storage facility. They know there's chemicals, they know there's pesticides in there, to be aware of it and to keep it locked up. You don't want people or the general public to just go or be able to go in that storage facility and take whatever chemicals or puncture them or whatever. You need to keep that locked up unless it's the people that are applying that pesticide. Keep it in good condition. Don't have things blocking the doorway, have some ventilation in there, that sort of thing, if at all possible. Do not store your personal protective equipment in there, but you want to have it close by, and you've also got to have decontamination, like towels and water, things that you can wash your eyes out with. If somebody gets some pesticide on their hands or on their person, you need to have something very close by to be able to address that. Like an eye washing station and all that kind of stuff. Sometimes on these pesticides, they have actual instructions of how to store it. So you have to look at the label again, because the label is the law. They may be very specific. So the location and structure, they want you to have it downhill and downwind from vulnerable areas like surface water, sinkholes, and wells. You don't want there to be any possibility of, if there's a leak, that it would drain and get down into some type of surface or groundwater facility. The building must be 12 inches higher than the surrounding soil. Keep away from flammable structures, obviously, pipelines, electrical lines. You want your floors and walls structurally sound, so people can't get in and out. Inspect the chemical containers regularly, because we all know that over time, especially plastic containers, tend to get cracks in them and things like that. So you need to look at them pretty regular to make sure that there's no leakage. Keep your bag goods off the floor to keep them dry, and have a proper cleanup safety equipment available. Lock and post signage on the building with contact information for emergency, like the hospital, nearest doctor, things like that. So you need to have all this information available to whoever is applying the pesticides. Now, the general farm BMPs, these are just a few things, regardless of what you grow, what you raise, what pesticides you put out or whatever. Looking at your used oil and used tires and things like this, you can conduct a self-assessment that the Ag Center has. It's called Farm Assist and Home Assist. Basically, it goes through a checklist of things that you're doing in your home, or where you dispose of certain chemicals and things like that, and it gives you an idea of what to do with them. Dispose of your oil and grease and batteries properly. This means collecting your used engine oil in a waste container until it can be recycled. Empty paint cans, antifreeze containers, used tires and batteries, putting them in an area, until you can find somewhere to dispose of them properly, not throwing them, in the back 40. I know, like, has happened in the past, but there are proper ways to dispose of things on the farm. You just have to find out where they are. Fuel storage tanks, properly installing fuel storage tanks, that's a big deal. Plans for installing 60+ gallon tanks must be submitted to the State Fire Marshal's office. Any above ground fuel storage tanks are regulated in Louisiana by the State Fire Marshal and by EPA if they think there's any surface water at risk. Above ground tanks containing 660 gallons or more require some type of secondary containment, like that wall we just showed you. They also recommend a secondary containment with all fuel storage tanks. So not just above 660 gallons. They should be located at least 40 feet from a building and 150 feet and downslope from surface water and wells, obviously to protect against the potential of some type of spill or leakage. The guidelines for fuel storage tank installation are on the website for the State Fire Marshal's office, but they're also in the BMP manual. So if you want to access those on the website, all of that information for specific fuel storage tank installation is in there as well. And lastly, testing your irrigation water. For those of you that do irrigate, a lot of times we have trouble with salinity, especially in South Louisiana, and that's something that you want to address, because that can obviously cause problems in your crops. You can actually grab a sample from any discharge point in a clean plastic or glass bottle with some type of screw top. We do have other bottles that are at our labs that you can use to take samples as well if you're not comfortable with using one of your own. You refrigerate the sample and document the date and time it was taken. You fill out a chain of custody form that shows where you got it, and fill out what you want it tested for, whether it's salinity or pesticides. You deliver the sample within a required holding time to the lab. And it just depends on what you're having it analyzed for. But we do have labs, again, that can test for that if you're interested in knowing, you know, what the water quality is for some of the water that you're irrigating with or around the house. According to the EPA regulations for fuel storage tanks, what they consider, if it's more than 10% of the tank is considered underground. Sometimes you'll see fuel storage tanks, especially large ones, that are sitting on the ground kind of with a berm around them, like a soil levee type berm around them that actually kind of hold them in place. If more than 10% of that is considered underground, then the Department of Environmental Quality becomes a regulatory agency for oversight instead of the State Fire Marshal's office. So, you know, if a person wants to deal with the State Fire Marshal or deal with DEQ, it's just recommended that if you have a tank in that situation, that you get it up out of the ground and you get a retaining wall around it to be able to stay under the State Fire Marshal's office regulatory oversight instead of DEQ. This is a spill prevention, control, and countermeasure program. That's something you may or may not have heard of, depending on if you have fuel storage tanks on your farm. I just kind of pulled these up. You can't really see a lot of it, but it has on the website. We have it a fact sheet. The Ag Center actually has a fact sheet too. If you go in the search engine and put SPCC, it will actually pull it up. It's just kind of an overview of what this program's about. This is through the EPA's office, but what it is, it explains, if you can see on the left, is to prevent oil spills into the waters of the United States and adjoining shorelines. And you have to find out whether your farm is covered under this program and if it applies to you. And they have several websites that you can look under, you know, if you're curious about that. If you haven't heard about it before and you think it may apply to you, you know, then I would suggest that you visit that website and kind of do a self-inspection of what you have and what you need to do to meet the requirements of that program if you qualify. So that's kind of a lot of information in a nutshell. You know, again, these are not all of the BMPs.